In this lesson, we'll discuss solving quadratic equations by using the quadratic formula. The basic quadratic equation is of the form ax squared plus bx plus c is equal to 0, with a, b, and c representing numbers. And of course, a cannot represent 0 because 0 times anything is 0, then we wouldn't have a square term, which means we wouldn't have a quadratic equation. But to be able to use the quadratic formula, each quadratic equation must be set equal to 0, and it must be descending order. And by descending order, we mean this is a degree of 2, then follows the degree of 1, then follows the degree of 0, which is also referred to as our constant term because there is no variable with it. Our quadratic formula, if we took this quadratic equation, completed the square with it, when we solve it for x, this is where the quadratic formula comes from. And I stated that x equals, it could be any variable, but we typically use x, but x equals to negative b, and that means the coefficient of x plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And so when we use the quadratic formula, if we set the equation originally to 0 in descending order, then all we have to do is substitute in the coefficients and constant terms for these variables. So we're going to look at 3 different examples. In this first example, the equation is already written in descending order as well as being set equal to 0. So I would come over here and I would write down what my a, my b, and my c represent. And remember, the equation is ax squared, so in this case a would be 7, b would be negative 2 as x's coefficient, sign and all, and then c would be positive 3. So then we would substitute in our formula. We would have negative b, and that first negative sign is because of the formula, and then the second one is because of the number, plus or minus the square root of b squared, and put that in parentheses, minus 4 times a times c. And this is all divided by 2 times a, which in this case would be 2 times 7. The next step after substitution is to simplify and eliminate the parentheses. So in this first number, a negative times a negative would give you a positive 2 plus or minus the square root. Negative 2 times negative 2 is positive 4. And this part of the problem, we're actually multiplying those 3 numbers together. The first thing I would do is look at the sign. In this case, we have just one negative sign, so it remains negative. And then we would say 4 times 7 times 3, which is actually 84. And we divide it by 2 times 7, which is going to be 14. So at this point, we do not have any parentheses. And then we simplify from here, adding what's underneath the radical. So we would have 2 plus or minus the square root. 4 minus 84 is actually negative 80 divided by 14. And in this case, we have an I because of the square root of a negative number. We need to break 80 down into prime numbers. 80 divided by 2 is 40, 40 divided by 2 is 20, 20 divided by 2 is 10, and 10 divided by 2 is 5. Because it is a square root, we're looking for pairs, so we actually have 2 pairs of 2's. So because there's 2 pairs of 2's, that means a 4 is going to go in front of the radical, a 5 is going to go underneath the radical, and that negative sign is going to be an I outside of the radical, and you can actually put that before or after. And in this case, if you look at these 3 whole numbers right here, they all divide by 2. So for a final answer, we would have 2 divided by 2 one time, plus or minus. In this case right here, we would have 2. I'm going to move the I out front of the radical. Divided by 2 divided by 14 is going to be actually 7. So as their final answer, entering this into course compass, we would actually write this as 1 plus 2i square roots of 5 divided by 7, comma, 1 minus 2i square roots of 5 divided by 7. This would be the 2 solutions. In the next example, we have to first set this equal to 0 before we start using our quadratic formula. So it doesn't matter which way this is moved. I'm actually going to move the 4x to the left and the negative 5 to the left, so it becomes 2x squared. That positive 4x becomes a negative 4x, and the negative 5 becomes a positive 5, equals to 0. And then I identify my a is going to be 2 because it's x squared's coefficient, b is going to be negative 4, and c is going to be positive 5. So substitution-wise, in the formula we would have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then we would simplify by eliminating the parentheses. A negative times negative is going to give you a positive 4 plus or minus the square root. Negative 4 squared is 16. Again, we're multiplying these three terms. There is only one negative sign, so it remains negative. 4 times 2 is going to be 8. 8 times 5, which is going to be 40. All divided by 2 times 2, which is 4. So at that point, we do not have any parentheses. Simplify by adding the two numbers underneath the radical, so we have 4 plus or minus the square root. 16 plus negative 40 is actually going to be a negative 24. All divided by 4. So we have 4 plus or minus, and in this case again we have an I. We need to look at the 24 in prime numbers, or factored into prime numbers. So 2 divides into 24 12 times. 12 divided by 2 is 6. 6 divided by 2 is 3. So we have a pair of 2's, and so that's going to give us 2 square roots of 6 with an I. All over 4. And again, these three numbers all reduced by 2. They all have to reduce, or you just leave it the same. So 2 divides into 4 2 times. 2 divides into 2 1 time. I'm going to move the I in front of the radical. And then 2 divides into 4 2 times. So as far as the final answer is concerned, we're going to write this as 2 plus I square roots of 6 over 2, and then 2 minus I square roots of 6 divided by 2. In this next example, again we have a quadratic equation, but we only have two terms. So in this case we still need to set it equal to 0. So we're going to move the 3 or subtract 3 from both sides. That becomes a negative 3 equals 0. So our A is equal to 4. Our B is equal to 0 because there is no x term, and B is always the coefficient of x, and C is going to be equal to negative 3. So as far as the formula is concerned, we would have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And in this case, when we simplify this, we do not need the 0 right here. We have the plus or minus square root. 0 squared is 0. Right here we multiply, we have two negative signs, so that's going to be a positive. 4 times 4, which is going to be 16, and then 16 times 3, which is going to be actually positive 48. And then multiply the denominator, 2 times 4, which is positive 8. Looking at 48 to see what type of prime numbers this breaks down to. 2 divides into 48 24 times. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So we've got two pairs of 2's. So we would have 4, because that's the two pairs of 2's, square roots of 3 divided by 8. Now these whole numbers reduce right here, so I am going to reduce those to a positive square root of 3. 4 divides into 8 2 times, and a negative square root of 3 divided by 2. And in that case, those would be our two solutions.